So you have like this blob of data, right? And now you want to do something with it. And in particular, we're thinking about searching for it. So we're on to the scrubbing phase. And usually, you dedupe things, you lowercase things, you remove punctuation, like kind of lots of the low-hanging fruit that you don't really need like a library or a fancy algorithm for. Like you guys were saying, like looking for the first 3 lines or 3 letters of something, whatever. You don't need a library for that. You just probably if you've done it more than once, you have a regex string that strips punctuation, and you just pull it out from like whatever your last project was. So imagine we've got a file full of tweets, and they've all been lowercase and all the punctuation's removed, and we just have these tweets all in a row. So there's a common algorithm in a lot of natural language processing, right? And it's just stemming. And what stemming refers to, if I say stemming or like porter, right? How many people, can I just get how many people is that foreign to? How many people does that boring to? Boring? Yeah. Foreign first? Foreign. Okay, cool. That'll make this easier or more interesting. So stemming, right? Like a tricky thing in natural language, right? If you're looking at something, like say this tweet is about oranges, and the next tweet is about an orange. And you're trying to build an index of words. Well, like oranges and orange, to us, right, we know that's the same word. But to explain that to a computer, that's much more difficult. So there's these stemming algorithms that basically break words down. They just kind of drop all the suffixes. So like orange, after it's been stemmed with a Porter stemming, whoever knew that is like the most common one, might just be like the string O-R-A-N-G. And oranges will end up just being like the string O-R-A-N-G. So you run all your words through this, and they're not really English anymore, but they're kind of normalized into something that tries to ignore plurals. Did that make sense, kind of? All right. Imagine a slide. So here's where the little interactive shell, you type in a word, it gives you something else. So Porter stemming is like a really common one. There's a Python library called stemming, which is really, really great. And so basically you pip install stemming, and you go from stemming .porter import stem, and then you just type stem word. And it's really great. Like you guys were talking about library design. The way they've implemented that, right, where from library.algorithm import stem, if you want to use a different stemming algorithm that might be more appropriate for your data, right, like all you do is up where you import it, you just change the algorithm you're importing from, and all the rest of your code will work with the same stemming. So I mean, that was something that was nice. Like you can kind of explore on. So the stemming library, I recommend it. It's cool.
Maybe you should explain what pip install is.
Oh, yeah. How many of you know what I mean when I say pip install? How many? Nothing. Okay, so Python has a package manager. It's had a few package managers. But the leader of the pack right now is called pip. So basically when you want to install a Python library, there's like an 80% chance if you just type the letters pip space install space package you want to get, it'll find it. So, just try that first, and if it doesn't work, go find someone who can install it for you. So stemming is really cool, and that's like basics, remove kind of the cruft from the English language, so you have this base thing. Another set of algorithms that are really interesting to me are metaphone stems, basically. And a lot of this comes from the fuzzy library, which also implements Levenstein distances and whatnot. And the thing that's cool about the fuzzy library is that the algorithms are actually implemented in C. So you get like these really clean Python bindings to this compiled sort of stuff, so it's fast, right? The gist of like the fuzzy stemmings, and like this thing called the double metaphone is what I was going to show you. It basically breaks words down into even more coarse of a block, and this guy has summed up the entire English language. He can make any word out of like 16 pairs of 2 letters. So like apple turns into AP, and like, I don't know, rice turns into like RZ. And so it's based on how the word sounds, not as much the letters in it. Okay, so what that's really useful for is like these really, really fuzzy matches, where you kind of remember how to spell something, maybe, and you can kind of munge it in there, and you'll get lots of like weird results, but you'll probably get the one you're looking for too. So yeah, those are kind of common algorithms that you use on data. So we've gone through, okay, you mine all your data from the Twitter. You clean it up, you stem it. You stem it, so you have these nice, neat little packages of data. So now you could build your index, or you can do like further analysis on this. So I want to talk about one other algorithm that is pretty common. It's called Tf-Idf. So let's do the whole. Anybody know what I'm talking about? Some? And anybody totally baffled? All right, so I'm going to treat you like you're all totally baffled instead. So Tf-Idf is actually like not a very difficult algorithm. You're going to hate me. I'm going to like way oversimplify this. He's going to think I'm an idiot. But the gist of it is like you have Tf, which kind of stands for term frequency, I, which stands for inverse, and Df, which stands for document frequency. And so like all you do is if there was a tweet there that has like 6 words, right? You just count the number of times each of those words shows up in that tweet. So I think my example was like a tweet of like this is totally like the best like chippy ever. And so if you add that up, right, there's like 3 likes, there's like 1 totally, 1 chippy, 1 whatever else I said, right? And then you take that data, and so that kind of represents like your little tweet. And then you look at something called a corpus, which is like every word ever. Like you just, like every word in the English language. And you count how many times they show up. And so a good kind of like, a good way to get like a decent corpus is like the Wikipedia dump. And it's actually like a pretty fun little programming challenge also because it's big. Like you can't load it into memory, as someone pointed out. And you basically just count like every word and really every stem, right, that shows up in Wikipedia. And so then you have this feel for how many times, like how common a word is the word totally? How common a word is the word like? And so Tf-Idf is literally just like, okay, if like shows up 3 times in my tweet and it shows up 100 times in Wikipedia, I bet it shows up more than 100 times. Like it'd be a Tf-Idf score of 0.03. But if chippy only shows up once in the tweet, and maybe it only shows up like 10 times in all of Wikipedia, it would have a score of 0.1. Okay, so like rarer words sort of get a higher score. Words that appear more in a document get a higher score. Okay, so this different ways of manipulating this algorithm, and this is what Lucene does. Like if you use Solr, and you're using Lucene, you might not know it, but this is like relevancy. So when you search for something and it says, okay, well this has a relevancy score to this document of 0.08 or whatever, that's the Tf-Idf score. And this is literally just counting words and comparing it to all the other words. So that's good for knowing, like if a document has the word cucumber in it 4 times, you can get a feel for, oh wow, that document's probably about cucumbers. So if a user's searching for cucumbers, right, you basically just end up giving them the document that has that word the most times in it, which is okay. And like this is how primitive search engines like work, like 1st generation search engines use this algorithm. But obviously like it's not foolproof, it's not great. Like it was open to all sorts of exploits and people just throwing keywords in there because holy shit, now it shows up 5 times in your document and you move up the ranks in Google. Yeah, go for it.
I'm sorry to interrupt, but I think it's important that the corpus is supposed to be context dependent, so it shouldn't be everything.
Yeah.
Like, if you look at a tweet, it should be like the universe of the tweet, not like,
Yeah.
because like, and we wouldn't say like totally like, but we would say that.
Right. So what he's saying is an important part, or where I was heading, is that the corpus, I'm using Wikipedia as the base example, but you can use lots of things. Like he's saying, like if you add up all the language in tweets, you'll get a totally different corpus than if you add up Wikipedia, right? But so also then, like say you add up all the tweets for a user, and you use that as a corpus to kind of classify the tweets, but then you use that corpus as like a term frequency against Wikipedia to kind of classify the user, right? So this is kind of one of the reasons I think it's interesting to know how these algorithms work, is that you can play around with them, and there's like he's saying, like really interesting ramifications and like insights that are in your data just by kind of, you know, moving parts around. Is that all right? All right. So Tf-Idf, so you've scored all this thing. In the demo I was going to do, I didn't use Tf-Idf scoring because it doesn't make a lot of sense for tweets, right? If you look at a tweet, it's 140 characters. You very rarely get the same word more than once. So it's basically, like a search engine is pretty much just like the number of words that have showed up in that tweet. Like the more words, it's going to show up higher in an index. Exciting. Okay. So Tf-Idf is used for ranking search results. It's also like a really interesting kind of classifier. If you take the Tf-Idf scores, right, for all the tweets in a user, the ones at the top will kind of classify that user. So like if you need to sum up a Twitter user in like 4 words, you can just take like the highest 4 Tf-Idf scores, which sounds kind of like bullshit, but I'll tell you an amusing story, maybe, hopefully. I have a friend named Charles Hooper, and I was kind of teaching him this, and he was like, oh, that's interesting. So he set up a Twitter bot called The Bookie, and he would scrape a user's tweets, pull out the highest 5 words, send those to the Amazon search engine, and find like the top result for a book. And then he would tweet at the user, hey, have you ever read book blah, 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 blah. And he was making like $100 a month because people, like 50-50, were actually really interested in what that book was. So he got banned, right? But if you Google for his bot, he lives on Favestar because all these people have favorited his tweets because they were great recommendations. So don't knock. Like simple algorithms can do interesting things. Yeah.
A clarification point. So what he's doing there is he's saying not what are those common words in the street in this set of tweets, because if you did that, you'd get a lot of A's and B's and I's.
Exactly.
And what are the most frequent, unique words, right?
Let me sum up. Yeah. So what he's saying is it's not just like if a user uses a word a whole bunch of times, because you'd get the noise. You know, you'd get the likes and the thes and the noise. But it's using rare words that bubble up higher, right? Because then the denominator is much smaller, the numerator is higher, right? Yeah. Excellent point. Cool. Okay, so we've talked about scraping, we've talked about scoring, we've talked about scrubbing. The last step really in making like a full project is indexing. So I've been really fond of a thing called redis lately. Anybody know redis? Yeah. I really like a web framework called Tornado. Yeah, cool. Imagine like a killer demo, it works. It doesn't. So the thing that's cool about, yeah, right. So the gist of the demo that I built for this is you go in Redis and you take like every stem in a tweet, and you use Redis's sorted sets. And so like Redis is a key value store. And so you'd basically look up the key for that stem and then increment in the sorted list by whatever your scoring metric is. So it could be the Tf-Idf score, it could be like a timestamp, it kind of depends on what your data is. And so then on the user's facing side, when they type in a word into the search engine, right, you look up that stem in the index and then you have like the top 5 results and you know, oh, okay, based on whatever my arbitrary scoring metrics were, these are the best results. So, like literally, the scraping with Twitter tools takes like a dozen lines of code, right? The stemming with fuzzy and stemming takes like a dozen lines of code because you just import and stem and whatever. Like scoring, if you're not doing Tf-Idf, is a couple dozen lines of code. Dumping it into an index is just like iterating over those stems. You're like another couple dozen lines of code. And then the Tornado front end, right? If you've worked with Tornado, you know it's pretty brief. So the whole demo clocked in at like 175 lines of code. and maybe another 50 or 60 on the front end for some JavaScript to glue it together. So the point being, like, search engines are supposed to be this magical, mystical beast that nobody can possibly attempt to deal with. But it's actually totally doable. Like, if you understand a few algorithms enough to download the right package and use them, you can play with your data, and it's fun and interesting and satisfying. Go for it.
Is that demo up on like GitHub or something?
Yeah, it's all the code, all my slides, everything's in my GitHub account. It's just apparently not possible to hook that up to a projector today.
I'm imagining some really cool stuff.
Yeah, thank you. Funny cat pictures also. So, sorry, I mean, that was kind of lame, but if anyone's got questions, go for it.
So for building a form, be sure to use the microphone. Let me grab a microphone. Repeat the question then.
So it's on a GitHub account. I'll probably post it to the Japhy list. Seems like the way to go.
Yeah. Did you repeat it? Okay, we're done with that one. Next one here. Talk to the microphone so we can hear it. We don't have to repeat stuff.
All right, so you're mining Twitter data. You're mining Twitter data. How do you filter out the lols and WTFs and like something spelled SUMTNG?
Yeah. So in the case of like lols and WTFs, right? Like a really common practice is to just drop everything that's less than 3 or 4 letters. And that gets you 80% of the stuff. But for the misspellings, right? Like that's the point he was raising about how these corpuses are wildly different. Where if you compare the words that are happening in Twitter to the words that are happening in Wikipedia, like those differences can actually reveal really interesting things. So you don't necessarily want to get rid of those. And I'll give you an example of this. I built a thing that was doing the same kind of basic structure, and it was trying to like map and cluster Twitter users. And so it was this algorithm that I thought was really great and might work. So this was just a test. I had like Shaquille O'Neal, and I had like some French people, and I had my friends, right? And my algorithm, all the French people kind of clustered up here, all my friends clustered up here, and Shaquille O'Neal clusters off here. Because, right, like he's using totally different language than everyone else. So, yeah, you should decide, like the stemming algorithms won't deal with those, but they're potentially as valuable as anything else.
So you have the whole tweet, and it's like, lols, this is hilarious. Do you use the corpus to kind of emphasize that this might be funny and do anything with that?
So that kind of speaks to like sentiment analysis, right? What I've been talking about is basically there's no correlation with what a word is and what it means. And it's surprising, like the bookie, right? It has no idea what any of these words mean, and it still can kind of match stuff up. So it's good for clustering and kind of that sort of thing. But yeah, sentiment analysis is when you start training individual words and you build up another index or I don't know if you call it a corpus, of that sort of thing, of, okay, does this word have positive connotations, negative connotations, et cetera?
Wait.
Would that apply to, would that apply also to situations like autocorrect?
Yeah, I'm actually building an autocorrect at work right now. Yeah, there's different ways you can go about that, but
I mean, if you've got a lot of autocorrect happening
yeah.
in your Twitter posts, can you compensate for
Oh, so like you're detecting that people are using like really uncommon words and that probably the autocorrect was wrong?
the autocorrect has garbled their message?
Yeah. It's something that I'm kind of surprised that nobody does, right? Because you can tell, like Google Translate or autocorrect, right? When it spits out a translation, a lot of those are really obvious to an English-speaking person that's utter gibberish. Because like nobody has ever said those words in that order, right? But so a really interesting thing is if you Google for like a phrase, right, and it has like no results, like maybe you could tell that that's a shitty translation. I don't know. Yeah, exactly.
Or it's like an idea that like no one...
Yeah, right. So either you're groundbreaking or there was a bug. Yeah.
There's a question back.
What's the benefit of using redis and the libraries that you used compared to NLTK and something like Whoosh?
So actually stemming is extracted from Whoosh. I think they're the same guys. Yeah. It's just all about, I think that stemming and fuzzy hit a sweet spot of, they're really easy to use. They implement pretty much all the algorithms you'd want to use. And you don't, like, implementing those algorithms can get a little hairy. So like you can kind of understand them and then you can take them out and play with them, but they aren't imposing themselves on what you're building, right? Like it's like the stem example. Like it's very minimalist. You just end up with like one function. You can plug them into other things. Redis, I feel kind of hits that same sweet spot where it's kind of low level, but it's very, very flexible. And it's not, you know, as soon as you start touching an SQL sort of database, you almost immediately get ORMs and schemas and whatnot. You know, Redis is like in the code, like there's only maybe 3 or 4 lines that actually touch Redis. You know, it just plugs in really cleanly and you can use it to do interesting things.
Okay, last question. Last question. That's a statement. Lettuce owns. Let us entertain you. Last question. Make a good one. Come on. Give it to me, folks. Meaning of life? Meaning of Japhy? Anyone? Anyone? All right. Thanks very much, Japhy. That was awesome. I have to say, man,